Wonderful. Thank you very much. It's great to be here, and thanks to the organizers. So I've been asked to just talk 30 minutes on how to fix climate and everything else. So I'm going to make three main points. One is, look, global warming is real, but let's get a sense of the proportion. It's a problem. It's not the end of the world. That's important because if we panic, and that's often how we think about climate change, we're unlikely to make good choices. So the second point I want to talk about is how is our current policies working? And the short answer is not very well, but there are much smarter policies. And then the third point, and I'm only going to touch briefly on that, but that's because that's part of my day job, is to say there are lots of other problems in the world. A lot of people want to do something for climate change because they want to do good. That's wonderful. That really is genuinely helpful that people want to help the world. We heard the Monsignor tell us that we need to make sure that we leave a good legacy for us, for our human compatriots and the world. But of course, the question is global warming the best way to do that? And I'll also show you, well, there's actually a number of other things that we could do that would do more good. So let me just get right into it and say, look, first of all, yes, global warming is real, and it will, in the long run, have a significant and negative impact on humanity. But how much? Well, we actually know. Right now, the UN estimates global warming has about a cost of 0% of GDP. So across the world, we actually have about zero impact from global warming. That's certainly not what you hear from the news. That's not what you think. And remember, this conceals the fact that many in the developing world and in the hot parts of the world are suffering from global warming already, but many places in the rich world, in the temperate world, we're actually still benefiting from higher temperatures. I come from Denmark. Not surprisingly, we don't think global warming necessarily is such a bad thing. It will be, but not quite yet. And this is what the cost, and this is again what the UN Climate Panel tells us. In the 2070s, we estimate the total cost of global warming will be somewhere between 0.2 and 2% of GDP. This means that the impact for the average person is the equivalent of losing income worth 0.2 to 2%. That is a problem. It's not the end of the world. This is actually the updated version from the UN Climate Panel. This is by Nordhaus. You might know that he got the Nobel Prize in Climate Economics just last week. And what it basically shows is temperature increase out of the x-axis. It's in centigrades, and I'm sorry, that's just simply the way almost everything is in climate conversation. Multiply it by about 2, and you're pretty good to go with Fahrenheit. And you have the impact on global output, so basically what's the income cost. And as you would expect, most of these are negative, so it is a problem. And as you can see, it starts about 0 here. There's some estimates that show it has a slight negative impact. There's one estimate here that shows that it's actually a pretty big plus right now. And then it starts declining here. So likely by the end of the century, we'll see an impact of somewhere between -2 and -4% of GDP. This is the fundamental graph and the fundamental insight, and this is what the UN Climate Panel tells us. It's a problem, it's not the end of the world. To many, that sounds wrong. That just sounds like, look, we know from media, we hear how things are getting worse and worse. Some good quotes you might see is Al Gore, who tells us that it's like a nature hike through the book of Revelations on the news every day now. And Obama, and again, he only speaks for a lot of other people when he tells us, look, there are more extreme droughts, floods, wildfires, and hurricanes. Let me just take you through those 4. And again, of course, this is because this is what everybody tells you, and we often hear things are getting worse and worse already now. There's a kernel of truth in most of this, and that, of course, comes from the fact that global warming is a real issue. But there's also a lot of misinformation, and it's important to sort of reel back and get a sense of how big of a problem is this. So take drought, for instance. We get the sense that there's more and more drought. But if you actually look at global drought, this is a data set from one of the latest studies from Nature, all the indicators of drought have seen declines over the last 30 years. So actually, the data tells a very different story from the stories that we hear in the media and everywhere else. And if you go again to both the US Climate Change Science Program, what do they say? Well, they actually says droughts have, for the most part, become shorter, less frequent, and cover a small proportion of the US over the last century. So it's just not correct when we're getting the impression that you see more and more drought. Again, from the UN Climate Panel, the IPCC, there's low confidence in a global scale observed trend in drought. And for the future, they estimate that we will see some parts of the planet get more drought. And this is a common feature. So we don't see drought increasing. Actually, we've seen it slightly decreasing over the past 30 years. There's no confidence in the trend. We've actually seen less drought, mostly in the US. But we probably will see more drought in the future. So there is a problem, but it's certainly not one we've seen now, and it's certainly not one that tells you this is the end of the world, this is something that we should panic about. Likewise with floods. So we hear a lot about floods, but what does the UN Climate Panel tell us? Well, there continues to be a lack of evidence and thus low confidence regarding the sign of trend in the magnitude and or frequency of floods on a global scale of the instrumental record. We don't even know if it's going up or down. If you look at one indicator on flooding, take a look at the trend in the cost of US flooding, and what we've seen since 1930 is that it has been the declining trend in terms of GDP. Now, you have to adjust for GDP because obviously as we get richer, you'd expect that you actually see more damage. Notice that what this basically tells us is that even if there was a signal, which we can't actually detect right now, it is swamped by the fact that because we get richer, we also get better able to deal with the problems of flooding. This does not mean that there's no problem, but again, also get a sense of how much is global warming actually likely to impact this. The cost is already down to about 0.2% of GDP. So the increase that we're seeing, and we're actually seeing a decrease, is very likely to be on an order of magnitude lower than that. And what will happen with future flooding? Well, and this again, one very well respected by pretty much all of the big researchers in flooding research. If you look at the worst case warming, so the most warming that we could possibly see, the highest population so that the most people will be impacted, the lowest GDP so the people who will be least able to handle it. So the worst case scenario in all kinds of ways. What will happen? Well, if you look right now, we estimate that about 3 million people on average get flooded every year. That has a cost of about $14 billion globally. So a significant cost, but again, remember, it is a very small part of global GDP. So it's about 0.016% of GDP. That's, of course, why all of these, when you add them up, become a very, very small number. But if we don't adapt more, when sea levels rise, when they rise to about 3 feet more, which is the upper end of what we're expecting to see by the end of the century, you will see a dramatic number of more people being flooded. Actually, the estimate shows that you could get up to 329 million people being flooded every year. That's just a consequence of, if you just see a dramatic rise in sea levels and everybody stay the same that they've been the whole time, you will get a lot of people flooded. You will get a huge amount of cost. So 17 trillion cost, almost 5% of GDP. But the crucial bit here is to remember, this is if we assume that there's no adaptation. This is basically assuming that as sea levels rise, we're all just going to be standing there and see the waves lap up over our feet and then our ankles and then our knees eventually and say, gee, this is not going to end well, and stay there for another 80 years. But of course, that's not actually what humans do. We build levees. We make sure that we control our environment, and we'll probably do this almost everywhere where there's any sort of economic value. That's what the studies show. And so what the studies show is also, if you add adaptation, see what happens instead. That's the blue line. If you have adaptation, you will end up with 1 million people flooded despite a 3 feet sea level rise. Because in a richer world where you spend more on adaptation, you will actually be more robust, more resilient, be less likely to be flooded. The cost will be $37 billion, but remember, out of a much higher GDP, which is why the total cost is going to be in the order of 0.01%. That's actually a lower cost. Now, there will be an increased cost because you also have to pay for the levies, and we estimate the extra dike cost per year will be about $40 billion. But the short question is, are we going to spend $40 billion to avoid $17 trillion of course? Of course we are. That's what we've done all the way through history. And that's why there's something wrong when we're being told, and this is very often the case, that we're being told, oh my God, a lot of people are going to get flooded. Yes, if you assume that they don't do anything, but any realistic scenario will actually likely see less people being flooded. It will have a cost. Here, we'll be paying about $40 billion globally by the end of the century. Yes, it will have a cost. That's why global warming is a problem, but it'll not be the end of the world. It'll not be everybody being flooded. Wildfire, we hear about this a lot, but if you look at the data, this is the typical data that you see from 1960, you see actually somewhat of an increase in burnt area, right? But of course, you gotta realize that you're only seeing a small part of the conversation. If you take the whole data set, what you're actually seeing is that there's much, much more burning in the earlier years. This is the data back from 1926 until today. And what you see is almost all of the burning happened in the early part of last century. Why did it dramatically decline? Because we got much better firefighting. We got much better ways of making sure that no fires break out. Of course, what's then happening is you build up fuel, and part of what you're seeing here is actually that there's more and more fuel, and hence you will see more burn, but that has very little to do with global warming. Now, again, we estimate that we will see more burning in the long run. Most of the global models show that we will probably see about as much burning of the planet by the 2100 as we saw back in the 1940s for the world. So yes, there will be more burning, but again, it's not a catastrophe. We've been there before. So yes, it is a problem, but it's not the end of the world. Hurricanes, last bit I just want to mention, to a large extent, they're the most prevalent, and they're obviously also the ones that have the biggest cost. What does the UN Climate Panel tell us? Well, globally, there's low confidence in attribution of changes in tropical cyclone activity, which is what they call hurricanes, to human influence. That's very, very different from what you hear. And actually, in the new report that came out 2 weeks ago, they reaffirmed this. Fundamentally, we can't see a human cyclone yet. This does not mean that the theory doesn't tell us that it's going to get worse, but we can't see it yet. For the future, we're estimating there'll probably be fewer, but they'll probably be stronger. But again, let's get a sense of proportion. Right now, all the hurricanes in the world cost about 0.04% of global GDP. So a problem, but again, not by any means the end of the world. If we didn't have global warming, this is a famous study from Nature from 2012, and one that is being repeated pretty much by everyone. If we did not have global warming, we would see a reduction in impacts of hurricanes because we get richer and hence more resilient. So we estimate that by the end of the century, the cost would be 0.01% instead of 0.04%. Because global warming will probably cause slightly fewer but slightly stronger hurricanes, we now estimate that the total cost will be 0.02. So there are two ways of looking at this. That actually means that global warming will be twice as much as what it would otherwise have been. And that's a true way of putting it. But of course, also notice it means it'll be half of what it is today, despite more global warming. And of course, 0.02 is a very, very small part of the issues that we're really talking about. So Are there fewer, more landfalling hurricanes? Well, actually, there are fewer of pretty much all the ways that you can look at. So category 2, 3, 4, and also all of the hurricanes. They all reduced over the last 140 years. Again, very contrary to what we tend to hear. And again, this does not mean that we're not going to see more strong hurricanes. That's what the theory is telling us. That's what the models are telling us. But even so, it will lead to fewer costs in overall. Again, if you look at U.S. death risks over the last 120 years or so, we've seen a dramatic decline. The one from 1900 is obviously the Galveston hurricane, which basically was the costliest and most deadly hurricane in U.S. history. Again, if you look at damages from U.S. hurricanes, you see the picture that many people will tell you it's getting worse and worse. It's getting out of hand. But of course, again, that neglects the fact that we're also a much richer and much more developed country. So if you look, this is Miami Beach back in 1926. This is the same place in 2006. And it's probably somewhat clear that if a great hurricane was to hit in 1996, yes, there would be some deck chairs that would be destroyed, but it wouldn't have the same impact as what happens when you hit in 2006. And so really what you need to do is to look at, well, what's the damage if you correct for the fact that many more people live in harm's way? Remember, we estimate that the U.S. population quadrupled over the last, since 1920, I believe, I believe it's 1920, it might be 1930, sorry. It quadrupled, but the US coastal population at the same time increased 50-fold, just simply because there's so many more people at harm's way. So if you actually correct this is the cost, if you just look at the US damage cost in inflation-adjusted dollars. But what would have happened if all hurricanes had hit the US as it looks today? Some researchers did this study, and it's been published a lot of times, and this is the latest update online. Then the damage cost would have looked like this. It basically shows you that the most damaging hurricane would actually have been the Great Miami Hurricane that tore right through downtown Miami in 1926. The reason why it didn't cost very much, it only cost about $100 million back then in inflation-adjusted dollars, was because there wasn't anything, well, there was not very much to be harmed there. But had it hit Miami as it looks today, it would have been the most costly hurricane. Again, no trend compared to what we're being told. So again, when you're being told, look, we're going to see more hurricanes, we're going to see more droughts, more floods, more wildfires, we're just simply not being told the correct answer. This does not mean that there's not a problem, but we need to get a sense of proportion. Maybe the best one graph that summarizes this is if you look globally on what are deaths from all kinds of weather and all kinds of climate, they've actually dramatically declined. This is from the International Disaster Database. So from floods, droughts, storms, wildfire, and extreme temperatures. We estimate on average every year about 500,000 people died back in the 1920s. Today, that number has been reduced by 95%. And that's despite the fact that we live about 4 times as many people. So the actual death risk per person has been reduced by 99%. Again, this does not mean that there's no increase in some climate impacts. Absolutely. It means that our development, the fact that we're much richer, vastly outweigh that and make it possible for us to live much more resilient and much better lives. So that was the first part of the argument. We need to recognize that this is not the end of the world, it's a problem. So how should we deal with it? Well, one thing is that people will have a tendency to say, well, why don't we just get rid of fossil fuels? You know, if CO2 is the problem, why don't we just stop with that CO2 bit? And of course, the important part is to recognize we don't burn fossil fuels to annoy Al Gore. We burn it because it powers pretty much anything we like about civilization. It gives us heat and cool, it gives us transport and food and electricity, everything that makes life good. And so it's really, really hard to get rid of fossil fuels, not because we don't want to, but because it powers so many of the things that really matters to us. So if you look at what is global energy in 2016, this is from the International Energy Agency, and the next data will be from IEA as well. That's the OECD for energy, and so the most respected organization, most respected organization on climate. They come out with their annual report in November every year. So this is the last one from 2017. This is how much we got of solar energy in the world. In 2016, we got 0.19%. Many people believe that we have lots and lots of solar panels and they're just increasing dramatically and fast. That's just not the case. It's 0.2%. Wind makes up 0.6% of global energy, and everything else is 99.2, right? We don't have any sense of how little the impact of solar panels actually make. This is the energy estimated in 2016 and then again in 2040. And remember, 2040 is assuming that everybody does everything they promised in Paris Agreement. If you look here, what really matters is coal, oil, and gas. And nuclear hydro provides a little bit. Biomass is basically a lot of poor people in third world countries burning wood, which by so many different ways is a bad idea, mostly because it pollutes indoors. And then you have a little bit of wind and solar and a smattering of other things. A lot of people like to point out, but if you look to 2040, there'll be more wind and more solar. That's true. But there'll also be more of everything else, right? So actually, yes, wind will go from 0.6 to 2.1, solar from 0.2 to 1.6. Wind and solar will still in 2040, if we do everything we promised, constitute less than 4% of global energy. Wind and solar is just not the main part of what's going to fix climate change over the next 25 years. It may in the long run be, but certainly when we look forward to 2040, it's not. If you actually look at the number of the percentage of renewables since 1800, remember, we've been spending the last couple of centuries getting rid of renewables. Back in 1800, virtually the entire world was renewable. And what has happened is in the last about 50 years, from 1970, we have gotten about 13% of our energy from renewables. Pretty constant. What is happening now, and this again is the IEA data, is that if we do all we promised in Paris, we will go up to about 19.3%. So we will move up, but not anywhere near, I think, what most people imagine. We will see a slight increase in global renewables, and more realistically, we'll probably get up to about 16%. So the real point here is to recognize we're going to do very little with our impacts from Paris. And to give you a sense of how much it is, let's just take a look at how much will Paris actually achieve. Well, fundamentally, we need to recognize that we have seen very little impact from climate policies. If you look at the decarbonization, so basically how much are we able to produce, how much energy does it take to produce a dollar? We see a dramatic decline every year of about 1.5%. But notice there's no difference before climate policy and after we had our first climate policy negotiated in Rio in 1992, or indeed in Kyoto. There's no difference. You can't tell that we've had climate policies for the last 20 years. And also notice, if we're actually going to be confident in doing our 2-degree target or anything else that we're promising, we would need much, much higher decarbonization rates. So fundamentally, what we're seeing here is our policies are not providing what we're promising. We're promising a lot of things, but we're actually not providing them. And let me just show you one thing. This is some of the work that I've done, and I think it's amazing and astounding that this is not more well known, because this is how we, I think, ought to think about the Paris Agreement. Everybody's hailing the Paris Agreement as this amazing breakthrough. Now we're finally getting somewhere with climate change. Let me just take you through this. So we have all the numbers. So what you see here on the left-hand side is how much CO2 do we emit. This is the historical emissions from 2000 until 2016. So we know very well how much we emit, and as you can see, we keep emitting more and more CO2. This is not just CO2, this is all the greenhouse gases, but it's recalibrated into CO2 equivalents. So this is the standard business as usual. This is UN, the Stanford Energy Modeling Forum, many others estimate that this is pretty much what we're going to see if we don't do anything about the climate. So we just keep on emitting more and more CO2. Eventually, we sort of get bored with it. We actually see that other technologies will take over, and so we see a gradual tapering off and eventually a slight decline towards the end of the century. How much will that result in temperature? Well, that's very, very easy. You just simply plug these numbers into one of the UN models, and you see how much does temperature increase. This is how much temperatures will increase in one of the most common models, the one that's been sponsored by the EPA and that's used in all the UN climate panel reports. So this tells you how much we'll see temperatures rise, so about 7 degrees Fahrenheit or about 3.8 degrees centigrade. So what will happen with Paris? Well, the UN has actually very helpfully told us this is what maximally will happen with the Paris Agreement, that we promised to cut this triangle out of our emissions. So how much is that? Well, that's about 56 gigatons of CO2. For most people, that has no meaning whatsoever, but just go with me, and that's the number. If you take the area of that little triangle, that's 56 gigatons. How much does 56 gigatons translate in the model? Well, you can actually see it out there. I'm just going to show you, and pay very close attention because you can't really tell the difference. Oh, that's the line that just came out up there. The difference is 0.04 degrees centigrade. Sorry, the centigrade is off out there, right? But you can still see it. A very, very tiny difference. So basically, if we do everything we promised in Paris, you won't be able to tell the difference in 100 years. But it could be that we not only did what we promised in Paris, but we would continue that promise throughout the century. So we would essentially be reducing what the endpoint of Paris promised every year. Remember, we've done no such thing with any of the other promises, but let's just go ahead and make this assumption. That would be the extended Paris promise. That would cut about 540 gigatons of CO2. What would be the impact of that? Well, you would actually just be able to see the difference in temperature over here. You'd actually see a reduction of 0.18 degrees or about 0.3 degrees Fahrenheit. So you can tell the difference, but only just. However, this is what most people actually told you was the outcome of Paris. That's the big thing that's called the Climate Action Tracker. This was what all the major news agencies and many politicians were arguing, that actually the outcome of Paris was that we promised to cut about 3,000 gigatons of CO2. Notice that there's a huge difference between promising, which is already a maximal estimate of 56 gigatons, to then saying, well, that probably means we actually committed to 3,000 gigatons. And if you did that, then you actually see a significant decrease of 1.1 degrees centigrade. This is how much you would have to cut if you actually wanted to get to the 2-degree target. This is how much you'd actually need to start sucking out CO2 towards the end of the century, right? That's about 6,000 gigatons, and that actually keeps you below the 2-degree line. Notice how much more we need to cut than what we promised in Paris. And of course, we promised it, we're not actually doing it. So if you put it very bluntly, the Paris Agreement constitutes less than 1% of what we need to do to get to 2 degrees. And how much will it cost? Well, thank you for asking that, because it turns out that it'll cost a lot more. Oh, and we're not living up to it, right? A new paper from Nature shows that all the major industrialized countries are failing to meet their pledges. So not only is it a tiny bit, but we're not doing it. And the cost will be significant. So remember, we spent a lot of money on subsidies. This is, again, the International Energy Agency estimates of all the different subsidies that we do right now. It costs about $150 billion in subsidies for renewables, and that will actually increase to about $207 billion. If you just take a look at what the cost is over from 2017 to 2040, we're going to spend, especially in solar and wind, we're going to spend $2 and $1 trillion, or in total about $5 trillion in subsidies. That's a lot of money. And that's not the only way that we're spending. We're also likely to see reductions in growth rates. So if you look at what's the growth rate and what's the CO2 growth rate, there's a very clear connection. So if you have higher outputs of CO2, you're also likely to have higher growth rates. And that's why all macroeconomic models estimate that if you try to cut carbon emissions, you will have lower growth rates, basically because you're replacing cheap energy with slightly less cheap energy. This does not mean that you're going to go to the poorhouse or that you're not going to have any growth. Of course not. It simply means you'll have slightly less growth. So what are the costs of the Paris Agreement? Well, unfortunately, there's no official estimate, which is kind of surprising that we're deciding to make such an agreement and nobody's actually looked at the costs. We now have the cost of the Kyoto Protocol, but of course that's a little late to have that, and the researchers will eventually come to that. I've tried to piece it together with some of the best period models, but it is not the ideal way of doing it. But it gives you a sense of order of magnitude. So I'm using the average of the best energy economic models, typically from Stanford Energy Modeling Forum. They typically model as a reduction in GDP growth, and I'm just giving you the very quick version here. For the US, if the US had decided to carry through on its Paris Agreement promise of right now Trump is not going to do that, the cost would have been, with the most effective policy, about $150 billion a year. For the EU, for their promises, that cost would have been about $300 billion. For China, we estimate it would have been about $200 billion, and I should preface that with saying that China is the most uncertain of all of them because we really don't know what will happen with China. Some estimate that it'll basically stop emitting as much very soon. Some models estimate that China will keep emitting more and more. Mexico is the other developing country, so we have very good estimate on what their promises will cost, about $80 billion, and the rest of the world is simply assumed that's about 15% of the total emissions. And they're assumed to be in scale with the other costs. And that adds up to about $924 billion a year. This is if everyone does all the smart things in the best possible way. Of course, that's very, very unlikely. We actually have good evidence that indicate that most climate policies are about twice as expensive. And if you do that, then you end up with a cost of almost $2 trillion. So $1 to $2 trillion. Again, if this was something where you got a lot of benefits, maybe it'd be worth spending $1 to $2 trillion. But fundamentally, it'll cost $1 to $2 trillion. We know that the cost of carbon is going to be about $123 to $246. The benefit, as estimated by Nordhaus, which we can also have a conversation about, is about $50. So it's likely that every dollar spent will deliver somewhere between 20 to 40 cents of climate benefits, avoided damage. That's not a very good investment, right? Give a dollar and get 40 or 20 cents back. That's why this is not the right way to do this. That's actually what Nordhaus shows. This is Nordhaus' latest model from this year, the guy who just got the Nobel Prize in climate economics. What he finds is that there are three different ways to have a policy. There's 4.1 degrees centigrade. That's basically, we don't give a damn. We'll just continue as normal and not have any climate policy. Then he finds that there's a 3.3 degree optimal policy, and there's a 2.5 degree policy that's going to be very, very costly. Not surprisingly, if you look at the climate damage over this century, he estimates the climate damage of 2.5 degrees will be in the order of $42 trillion. 3.3 will be more costly, and the 4.1 will be the costliest at $130 trillion. So this would seem to indicate, yeah, it's better to be 2.5 degrees to do something or even to do a lot. But of course, you also have to add that there's going to be a climate policy cost. And that climate policy cost is going to be a lot higher for 2.5 degrees. It's going to be somewhat smaller for 3.3, and of course, it's going to be virtually non-existent for the no policy option. This is what he got the Nobel Prize for. He basically points out, which is very sensible, to say that if you don't do anything, you'll probably have slightly higher cost. If you do too much, you'll also have slightly higher cost. And somewhere in the middle, you can actually optimize the outcome. But it's also important to get a sense of how much can you actually optimize it. The 2.5 degrees will cost 4% of GDP across the 21st century. The best and optimal outcome will be 2.3%, and the do nothing will be 3%. So there is potentially 0.7% to be gained over this century. That's the nice thing. That's, again, the point that this is a problem, and if we fix it really, really well, we can possibly do well. But remember, this actually also estimates that all nations manage to do all the right things at all the right times in coordination with China, the US, everybody else, with a common carbon tax across all areas, rising across the entire century. That is very, very unrealistic. If you look at the OECD right now, there's about 1,000 different CO2 prices. Would we really expect to have one? And would we certainly expect it to be also coordinated with all the developing world? If we don't, then it seems fairly likely to assume that this policy cost can increase dramatically and possibly even get beyond this. That, of course, is the real concern, that we will end up trying to do good, but ending up wasting more resources. Certainly, this is the very optimal, or very optimistic outcome. So which climate policies will work? Well, a good recession is always great. Had the 2008 crisis just lasted a couple of years longer, we would actually have achieved Kyoto. But of course, it's very unlikely that you can get most politicians on board for saying, yeah, we'll have more of those recessions, right? So another way to do it is to focus on solar and wind. This is the EU. We estimate the EU has actually cut about 100 megatons of CO2 with their solar and wind. That's good. But notice how much more the US has cut its emissions with shale. So you basically switched from coal to shale. And of course, while the EU is paying about $40 billion per year for this, mostly in subsidies, but also in lost GDP growth, you guys have probably made about $300 billion. So what would you rather do? Make a lot more money and cut more, or cut less but pay more, right? That's the real issue here, is to recognize that there are much smarter policies to deal with this, rather than just trying to put up lots of solar and wind. We did a policy study with 27 of the world's top climate economists, 3 Nobel Laureates, trying to look at where can you do the most good for climate. We actually found that dramatically the best investment is in investing in green energy R&D. So basically try to make next generation's green energy much, much more effective. This is also, if you've seen, Bill Gates has been very sort of following this whole conversation. He's also been very impressed. He's actually doing this now, and he was also one of the leading forces in trying to get the nations, both Obama and Canada and China and most of the EU, on board for doing this for the world, for spending much more money on research and development. We're suggesting that the world should spend about $100 billion on research and development. That's about 6 times more than what we're spending today. But the beauty is it would still be a lot cheaper than the current policy, and it would, unlike the current policy, have a much better chance of actually fixing global warming. So we actually estimate right now, and we don't have the global estimate for the global policy right now, but we do have it for the EU policy. We estimate that every dollar spent on EU climate policy generates about 3 cents of climate damage. Sorry, 3 cents of climate benefits, so it avoids 3 cents of climate damage. That's a terrible way to spend that money. But we also estimate green energy research and development will do about 500 times more good. It'll actually deliver $11 back on the dollar. So the 2 points I've tried to make here, and you want me to shut up pretty soon, so I'll just make this fairly quickly, is, look, global warming is a real problem, but it's not the end of the world. Let's start being smart about it, and let's start thinking about where can we spend money and do the most good for climate. Well, it turns out that that's green energy R&D. But of course, remember that there are many, many other problems in the world: poverty, hunger, disease. You know, if you just look at what are the world's biggest environmental problem in terms of death, it surprises many people. It's not global warming. It's actually indoor and outdoor air pollution. Indoor air pollution is somewhat surprisingly for most people. It's the fact that about 2.5 billion people cook and keep warm with dirty fuels, mostly wood, dung, cardboard, whatever they can get their hands on. And that pollutes their indoor homes so much more that it's about 10 times as polluted as outdoor Beijing. So there are many other environmental problems that are much bigger. And of course, people will say, but global warming is going to get bigger. Yes, but we also estimate in 2050, this is about how many people are going to die from global warming. It underscores, again, global warming is a real problem, but it by no means the biggest issue. Actually, this is not the right graph. This is the right graph. What's the biggest killer, not just environmental? That's poverty. Remember, there's a huge overlap between these now. You can't, because this is a third of everyone who dies on the planet. But poverty probably kills about 18 million people every year. So clearly, we need to ask ourselves, what are the main problems if we actually want to help people now and in the future? Well, the UN actually asked. They did this biggest survey ever of 9.7 million people, asked them all across the world, what would you like us to focus on? They gave people 16 different options, and here's the result. So most people actually said they'd like good education, and they would like health, jobs, no corruption, no violence, nutrition, clean water and sanitation, support for people who can't work, better infrastructure, equality, reliable energy, no discrimination, political freedom, protect forests and rivers and oceans, phone and internet. And at the very last bit, they asked for action on climate. So actually, of 16 promises, the world very clearly told the UN they want action on climate change to be dead last. I've given you the data link down there because the UN has removed this from their main webpage, probably because it didn't give the right result, right? But of course, this makes perfect sense. If you're poor, if your kids are dying from easily curable infectious diseases, if you don't have enough food, if they don't get a good education, those are the things that you really care about. And that also means we need to start thinking about, yes, global warming is one of the many problems the world faces. Let's spend some money to make sure we actually deal with it well. But let's also remember there are many other issues. We actually did this, and I'm just going to do this very, very quickly. We looked, and we're an economic think tank. We work with lots of economists to look at where can you spend money and do the most good. We looked at a lot of different things that you could do to help the world. We looked at a lot of climate and energy estimates. We, for instance, looked at what would it take to double renewable energy, which is one of the targets of the UN. It will probably do a lot of good. It'll provide more energy to many people. It'll do about about $415 billion more good per year. Unfortunately, the cost will be $515 billion more per year, which is why we estimate you'd only do 80 cents of good for every dollar spent. But we also saw other things. Climate change adaptation will do $2 of good for every dollar spent. Electricity to everyone will do $5. More energy research, as I mentioned, will do $11 of good. Phase out fossil fuel subsidies can do more than $15 of good simply because it enables many governments to do more good in other areas. And there are lots and lots of other things you can do. Mobile broadband will do $17 of good. Half coral reef loss will do $24 of good because coral reefs are not only valuable as biodiversity, but they also engage fisheries, they act as hatcheries, and they also provide more tourism for those places in the developing world where that's a big issue. Reduced child malnutrition will provide $45 of social good for every dollar spent. On health, many, many things, like for instance, cut tuberculosis death or expand immunization. We also looked at contraception for the places that miss it. We estimate you get $120 of good for every dollar spent. And for instance, trade will generate about $1,000 per person in the developing world towards 2030 per year. That's an amazing achievement. Every dollar spent will probably do about $2,000 of social good. What we basically try to do is to get a sense of where can you do the most good. And I'm just showing you a small bit of this. Actually, this is the full page that we did for the UN. Not that they listened very much, because that was not the main purpose of the actual exercise. But this shows you that there are lots of great things that we can do, and I'd love to share this with you afterwards, and we can probably talk about it here in the conversation. But fundamentally, what they tell us is, that yes, global warming is a big problem. Sorry, global warming is a problem. It's not the end of the world. We're tackling it very badly, and we can tackle it better. And then if it's about how do we do good in the world, yes, global warming is one of them, but there are many, many other places where we can do much more good. And I would urge all of us to try to make all those 3 points in order to get a better, more civil conversation, but also one that will actually end up helping the world a lot more. Thank you.